So, നമ്മൾ module 4 start ചെയ്യാണ്. Module 4 AC motors. Okay, module 4 AC motors. AC motors are classified into two. AC motors are classified into two: three-phase induction motors and single-phase induction motors. Okay, what is meant by a motor? A motor is a machine which converts electrical energy into mechanical energy. Here we are discussing about two types of AC motors: three-phase induction motors and single-phase induction motors. Three-phase induction motors convert three-phase electrical energy into mechanical energy, whereas single-phase induction motors convert single-phase electrical energy into mechanical energy, because motor is a machine which converts electrical energy into mechanical energy. Okay, so AC motors are classified into two: three-phase induction motors and single-phase induction motors. Induction motors runs essentially at a constant speed. Induction motors run essentially at a constant speed from no load to full load, and hence they are considered as constant speed motors. Actually, when load increases, there is a slight variation of speed takes place in the case of induction motors. Whether it is single phase or three phase, in all the induction motors there is a slight variation in speed takes place when load changes, but those variations are very slight. Therefore, we are calling these motors as constant speed motors. Okay, the main parts of a three-phase induction motors are stator and rotor. In this module, we are going to discuss about the three-phase induction motors. Okay, AC motors are classified into three-phase induction motor and single-phase induction motor. Motor is a machine which converts electrical energy into mechanical energy. So, three-phase motors converts three-phase motors convert three-phase electrical energy into mechanical energy. Single-phase induction motors convert single-phase electrical energy into mechanical energy. Induction motors are considered as constant speed motors. Actually, there is a slight variation in speed takes place when load changes. When load increases, speed decreases slightly. So we can neglect those slight variations. So we can call it as an induction constant speed motor. Okay, even then we can call it as a constant speed motor, because even though there is a slight variation in speed takes place, those variations are negligibly small. Therefore, we can consider these motors as constant speed motors. What are the main parts of a three-phase induction motor? In this module, we are going to discuss about three-phase induction motors. The main parts of a three-phase induction motors are stator and rotor. The main parts of a three-phase induction motors are stator and rotor. Depending upon the type of the rotor, three-phase induction motors are again classified into two: squirrel cage induction motors and slip ring induction motors. Three-phase induction motors are again classified into two: squirrel cage induction motors and slip ring induction motors. Squirrel cage induction motors are those induction motors which employ squirrel cage rotor. So what is meant by squirrel cage rotor? Squirrel cage rotor means the rotor is cylindrical in shape. Slots are provided on its outer periphery. Then copper strips or copper bars are provided on these slots, and whose two ends are electrically welded or soldered. Thus it is getting a squirrel cage construction. Therefore, these rotors are known as squirrel cage rotors, and hence these motors are known as squirrel cage induction motors. Once again, three-phase induction motors are classified into two: squirrel cage induction motor and slip ring induction motor. What about the constructional feature of a squirrel cage induction motor? The rotor of a squirrel cage induction motor is known as squirrel cage rotor. The rotor of a squirrel cage induction motor is known as squirrel cage rotor. What about the constructional features of a squirrel cage rotor? It is cylindrical in shape. Slots are provided on its outer periphery. Then copper strips or copper bars are provided on these slots. After that, whose ends are the ends of the copper bars are electrically welded or soldered. Thus the rotor is getting a squirrel cage construction. അടച്ചു പൂട്ടിയ ഒരു കൂടിൻ്റെ അപ്പോൾ നോർമൽ വൈൻഡിങ് അല്ല അവിടെ പ്രൊവൈഡ് ചെയ്തിരിക്കുന്നത്. ഇൻസ്റ്റെഡ് ഓഫ് എ നോർമൽ വൈൻഡിങ് കോപ്പർ സ്ട്രിപ്സ് ഓർ കോപ്പർ ബാർസ് ആർ പ്രൊവൈഡഡ് whose ends are electrically welded or soldered. Thus this rotor getting a squirrel cage construction. Hence this rotor is known as squirrel cage rotor and this motor is known as squirrel cage induction motor. That is the speciality of a squirrel cage induction motor. It is not possible to add the resistance to this external add the resistance to this rotor circuit. That means we cannot change the resistance of the rotor circuit because the ends of the rotor are electrically welded or soldered. The resistance of the squirrel cage rotor is fixed and small also. We cannot vary the resistance of the squirrel cage rotor. We cannot vary the resistance of the squirrel cage rotor. It is fixed. Okay. That is the speciality of a squirrel cage rotor. ഇതിൻ്റെ റെസിസ്റ്റൻസ് നമുക്ക് വേരി ചെയ്യാനായിട്ട് പറ്റില്ല. Then rotating magnetic field and synchronous speed. Rotating magnetic field and synchronous speed. When a three-phase winding is when we give three-phase supply to the stator winding of this motor, its stator consists of a three-phase winding. We have discussed about the rotor of a squirrel cage induction motor. Its stator consists of a three-phase winding. Stator consists of a cast iron frame. Slots are provided on its inner periphery. Stator consists of a cast iron frame. Slots are provided on its inner periphery. Then a normal three-phase winding, which is either connected in star or delta, is provided in the stator. So stator consists of either a star connected winding or a delta connected winding, which is fed from a three-phase supply. We are giving electricity to the stator winding of this motor. Then a magnetic field is developed in the stator. Then a magnetic field is developed in the stator, which is rotating at a synchronous speed. The magnetic field is rotating at a synchronous speed, which is given by Ns is equal to 120 F by P, where F is the supply frequency and P is the number of poles. So before that you have to understand one important thing. What is meant by synchronous speed? Synchronous speed means it is the required speed according to the frequency and number of poles. It is the required speed according to the frequency and number of poles. Okay, it can be denoted as Ns. Ns is equal to 120 F by P, where F is the frequency and P is the number of poles. So when we give electricity to the stator winding of a three-phase squirrel cage induction motor, a rotating magnetic field is developed at a stator, which is rotating at a synchronous speed, which can be found out by a simple equation. Ns is equal to 120 F by P, where F is the frequency and P is the number of poles. So a rotating magnetic field is developed in stator, which is rotating at a synchronous speed. Synchronous speed Ns is equal to 120 F by P. Okay, one important thing you have to point out that if in a single phase induction motor, that we will discuss in future anyway, when we give single phase supply to the stator winding of a single phase induction motor, it can create only an alternating magnetic field. But in the case of a three-phase induction motor, when we give three-phase supply to the stator of a three-phase induction motor, it can create a rotating magnetic field. But in the case of single-phase induction motor, the rotor construction of a three-phase squirrel cage rotor is same as that of a single-phase induction motor. Rotor is same in both cases. In the case of a stator, in the case of three-phase induction motor, stator consists of a three-phase winding. In the case of a single-phase induction motor, stator consists of a single-phase winding. When we give single-phase supply to the stator of a single-phase induction motor, it can create only an alternating magnetic field. It can create only an alternating magnetic field. That's a very important point you have to point out. Okay, so this is the introductory part of a three-phase induction motor. So AC motors are classified into two: three-phase induction motors and single-phase induction motors. Whether it is three-phase or single-phase, all induction motors converts electrical energy into all induction motors. All AC motors convert electrical energy into mechanical energy. So three-phase induction motors convert three-phase electrical energy into mechanical energy. Single-phase induction motors convert single-phase electrical energy into mechanical energy. These induction motors are considered as constant speed motors, even though there is a slight variation in speed takes place when load changes. Okay. Then the main parts of a three-phase induction motor are stator and rotor. Stator consists of a three-phase winding. Rotor is, we are discussing about three-phase induction motors are classified into two: squirrel cage induction motor and slip ring induction motor. First of all, we are going to discuss about a squirrel cage induction motor. Its rotor is known as squirrel cage rotor. The rotor is cylindrical in shape. Slots are provided on its outer periphery. After that, copper strips or copper bars are provided and whose ends are electrically welded or soldered. Thus, the rotor is getting a squirrel cage construction. Hence, this rotor is known as squirrel cage rotor, and hence the motor is known as squirrel cage induction motor. When we give three-phase supply to the stator winding of a three-phase induction motor, a rotating magnetic field is developed in the stator, which is rotating at synchronous speed. Ns is equal to 120 F by P, where F is the frequency and P is the number of poles. Okay.